Welcome. In this video, we will take a look at the sum and difference identities one more time. In this exercise, we want to look to write each of these expressions as a single trigonometric function using those sum and difference identities. So let's take a look at the first question A. We see in the first question A, we have a cosine of 3x, cosine of 2x, and then those same two angles, sine of 3x and sine of 2x. So we can consider in this example that angle A is 3x, angle B is 2x. So we have angle A, angle B. And so if we look at this closely and identify what sum and difference property we're using, if we do cosine, cosine, and then plus sine, sine, this would be the cosine difference identity. This would be cosine A minus B. So the cosine difference and sum formulas always have a change of sign in the middle. That's one way you can remember that one. And the cosines always start with cosine times a cosine. So in this case, we would simplify this with the cosine of A minus B. Well, that would be 3x minus 2x. Or we could just write that as cosine x. So there's our single trigonometric function equivalent to the original expression. The second example, we have another pattern going on. Cosine of 30, which we could call maybe an A angle. Sine of theta, we'll call this the B. And then sine and cosine of those same two angles. If we take a look at our, and recall our identities here, cosine sine plus sine cosine, that would be the identity for a sine. That would be a sine difference. Or actually a sine sum. The signs will have the same sign in the middle, so this plus indicates this is still going to be a sum for the sine function. And so we have the sine of A, 30 degrees, plus B, which is, well, here, theta. And in this case, we don't have any other way to simplify this with the theta variable, so we'll just leave it like this. Sine of 30 plus theta. And the last one we can take a look at as well. We have cosine of 15, which we'll call A. 75 we'll call the B angle. And so again, this looks like an arrangement for cosine because, again, we start with the cosines. And with the cosine, we always flip the sign in the middle, so this would be A plus B for that cosine. And so 15 and 75, I could rewrite in my cosine. This is actually cosine of 90 degrees. So this would be rewriting as one trig function, but we know that the cosine of 90 is equal to 1. So this whole expression is equal to just actually 0 there. Equal to 0. So cosine of 90 is always 0. All right, so that would be our expression. This would be the final kind of trig function there, but that would also be equal to 0 if we needed to simplify. So hope this helps with working with those sum and difference identities. This is also a good kind of practice to start to memorize the structure for each of these sum and difference identities. There's really only 4 of them, so if you can catch those patterns that we've been talking about, that that will definitely help when identifying them. So hope to see you in the next section. We'll take a look at double angles next in our upcoming video.